everyone, 2018 FRQs 3 through 6. I found that a lot of these, especially in this year, actually every question here is totally applicable to the exam. It's kind of nice. Remember, these are non-calculator questions, but here's the thing. This year, the AP exam is open note, so you might expect maybe some more difficult functions going on here. Or you might not, because again, they're kind of assuming everyone doesn't have a calculator readily available to them. So if you have a calculator, hooray. If you don't, we'll see. Anyways, let's go ahead and dive in. So it says if f is 1, what is the value of f is 5? But let's see here, g is the derivative of f. So if I want to know the value of f of negative 5, here's the best thing I can do. F of negative 5 is going to be, the best thing I can do is I can always say, the value of the function that I want is always equal to, do it like this. The last value I knew, which was 3, and that occurred at the value 1, and I need to get to negative 5, and I'll get there by integrating g of x dx. So this is what we call, I kind of call it the new position function. Now technically this might not be covered on the AP exam. This is typically learned in applications of differentiate or integration. So just be aware of that, but we can still calculate this problem. It's definitely still possible. So again, the idea is that f is going to be, f of negative 5 is going to be calculated by knowing where you were last known for f, which is 3 at 1. And you have to find out how much you changed, and you'll find out how much you changed by looking at the derivative of f and calculating the change that occurs from the x value you last knew to the x value you want to be at. And so there's definitely a lot going on here. So first step here, if I were going to solve this problem, is that it would actually end up being 3 minus the integral of negative 5 to 1 of g. So you can flip the bounds of integration to match kind of regular numerical order. And so now from there, here's what I'm going to do. I'm going to calculate this area using geometry properties. So when we look at negative 5 to 1, if we want the area under this curve for g, so minus, I'll put some parentheses here. First thing I see is from negative 5 to negative 2, I've got a square actually. There's 9 squares in here. So the area of the square is negative 9, or below the x-axis. Up next, I've got this little triangle going on right here, and it's got a width, or I guess a base of 1, a height of negative 3, and so it's going to be essentially negative 3 over 2 for the area of that triangle. Up next, from negative 1 to 0, there's 0 area, so I don't really have to add that. And from 0 to 1, again, I'm going to do this trick where if you kind of notice that if you cut this little piece right here and folded that triangle in, that would have an area of 1, or you can calculate it geometrically. So the value of f of negative 5 is going to be, let's see here, 3 plus 9 plus 1.5 minus 1. So in other words, it's going to be, what is that, 12.5. Or 25 over 2 is what they got. All right, up next they want me to just simply evaluate g from 1 to 6. So it's just straight up calculate the integral from 1 to 6. Here we go. When I calculate that integral, again, from 1 to 3, I've got a square that has 4 perfect squares inside there. And now I have to add that to the integral of what's going on from that quadratic from 3 to 6. And so I actually now have to integrate from 3 to 6 that quadratic function that they gave me. So 2 times x minus 4 squared dx. So that means I've got the 4 plus, and if I underive this, we kind of have a chain rule situation going on here, but if this last thing was squared, then it came from something cubed. Now, something else to think about here is if you do the chain rule with this, you're just going to have a 1 pop out, which is actually good because it is a chain rule, but not really, because the chain rule is just going to derive to 1 on the outside. So this will actually be the antiderivative, and we just have to deal with this antiderivative from 3 to 6. The 4 is tagging along from that that square before. So just make sure you understand how I'm getting this derivative. Again, when you integrate the inside, that integrates to 1, so multiply 1 to your 2/3, drop the power of 3 down, so now you're just left with 2, and then you reduce the power, so you're back to what you had before. So evaluating this from 6 to 3, I'm going to skip some of the work of that, but you have that 2/3 kind of hanging out there. 6 minus 4 is 2, so when you cube 2, you'll have 8, minus, again, 2/3 is technically distributing there. 3 minus 4 is -1. When you cube -1, you get -1. And so, let's see here, that's going to be 4 plus 9 divided by 3 is 3 times 2 is 6. So the answer should be 10. All right. And we're doing good on time here. Again, you should always be trying to give yourself only 15 minutes per FRQ that you do, because really that just ensures that you're always meeting the timeline. So if you can start answering these in 12 minutes with time to check your work, you are on a great track to do great on this AP exam this year. Up next for part C, on what open intervals is the graph of f increasing and concave up? Okay, so this is going to be a little bit more difficult, but remember, if, I guess I'll just say it verbally, I can't really describe that, but f is going to be increasing wherever f's derivative is positive, and f is going to be decreasing wherever its derivative is negative. So if I want to know where f is increasing, I need to know where its derivative, which was g, is positive. So wherever g is positive, that means the slope of f is positive, which means it's increasing. So where is g positive? Well, g is positive from 0 essentially to 6. So that is where g is positive. Sure, it's 0 in a few places, but overall, that's where it's positive. So from -5 to 0, it's definitely decreasing. The slope is negative. Remember, g is the slope of f. All right, so we want to know where it's increasing. And now we also want to know where the second derivative, and the second derivative of f is the first derivative of g. We want to know where the first derivative of g is positive as well, so that we know where it's concave up. So we definitely have to look at this analytically. And the other thing is we only have to look at this from 0 to 6, because that's the only place our criteria matters. So we have 0, and we have 6, and we'll see if anything happens in between. So if we look at the slope of g from 0 to 6, and I guess I should kind of specify again, the only reason I care about this is because it only has to be where they overlap. So anywhere where g, or in other words f prime, is negative, that's already out of the solution. So that's why I'm only narrowing in on 0 to 6. Right. Anyhow, so from 0 to 6, let's see here, the slope of g is positive from 0 to 1, and it's 0 until 3, so I guess I could say 0, that's kind of special. From 3 to 4, the slope is negative, and then from 4 to 6, the slope is positive. Alright, so for what open intervals is it increasing and concave up? So for my sign chart here, I've got that going on. I can conclude it is positive and increasing from 0 to 1 and from 4 to 6. And my sign chart is kind of my evidence for that. Alright, one thing you want to do is definitely specify that g is f prime and that f double prime is g prime. It doesn't look like they did that on the scoring line or on the scoring guideline, but it seems like it might be a mistake. But yeah. Now, again, you can kind of look at the scoring guideline. They did that in a little bit of a different way, but as long as you have your intervals and you have a reason, so that sign chart, you're good to go. And can I fit this on the last line, part D? Find the x-coordinate of each point of inflection on F. Now, this question I honestly hate. Now, the idea here is, gosh, I hate this question. But for each point of inflection, I'm kind of just going to go by the scoring guideline here. A point of inflection has to be like an instantaneous, quote unquote, change from negative to positive. In other words, I used to, when I first look at this question, I noticed that it's, G prime, we already have G prime, which is F double prime. And if we want to know inflection points, we have to know where it changes from positive to negative. And so there is a change from positive to negative in between 1 and 3. Because before 1 it's positive, from 1 to 3 it's 0, and from 3 to 4 then it's negative. But because it doesn't change instantaneously from positive to negative, since there's this lag where the slope is just 0, this does not count as an inflection point. So the only place we see like a quick or instantaneous change from negative to positive is at 4. So x equals 4. And again, that's because G prime changes from negative to positive, and G prime is F double prime. Is the scoring guideline really incorrect? Kind of seems... Yeah, the scoring guideline has some errors. Well, anyways, all right, that's question 3.